credit assignment for operational research. This extra credit assignment is cargo operations in port. So to start, we're just going to run the simulation and get all the numbers for 10 years. So we start with the simulation coming in. This is the ship arrival rate. So it's an exponential distribution, and on average, a ship comes in every 120 minutes, and there's 2 routes it can go. We have routing out from here, and as you can see, there's 2 probabilities. So it could go to either the berthing queue or it can go to the queue for offshore anchorage. So if we look here, go to results, you can see how many completed jobs came through offshore anchorage. So about 4,240 ships before they were able to go into the berthing station had to wait in the offshore anchorage spot before they were able to go to berthing. And you can see here that this was their distribution exponentially. And here in this queue, you're going to have every ship coming through. This was the before berthing queue. And then here it just evenly goes between all 3 of the berthing stations. So it's just same distribution to all 3 berthing stations. And from here, it's all exponential distribution. And you can see that it's 60 minutes for the timing. And that's the same across all 3 berthing stations. Then from these 3 berthing stations, after they go through, this would be like where the ships would be evaluated. This could be like, each ship has to go through a specific sized lane because, certain ships are bigger than others, so they might not fit. And once all of these go through, then they come into this queue where they either go to crane 1, 2, 3, or 4. And each of these cranes are a rounded distribution, so it either takes 20 minutes or 40 minutes. And each of these cranes also has a breakdown time as well as a resource use. So if you look here where it says crane operator, it's shift dependent. So if we click here on shift dependency, you can see that the availability is 4 for the morning and 2 for the evening, and the shift work patterns are right here. So it starts at 12 for the evening shift and ends at 8 p.m. and the morning shift is 9 a.m. to 12. So close that, and this is between all 4. So basically during the evening there's 4 operators and there's only 2 operators during the morning. So at any given time during the morning, 2 of these cranes will not be working. And this also goes along with the clock properties, which is, if you look here, runtime each day is 9 to 11. It's 9 a.m. and it runs for 11 hours. And so to talk about the breakdown time on these, if you look where it is, click here, and you click on it like this, click on properties, you can look here at efficiency, and I have current breakdown type is breakdown type 1. So if we click on that and we do time to repair, you can see it's lower bound of 5 and upper bound of 10. This timing is, or time, and then time between breakdowns. So we have it as 730 work days. So every 730 work days it breaks down. And then for the time to repair, we have it as 5 to 10 work days. And once it breaks down, it completely stops work immediately until it's fully repaired. And if we look at the result on these, you can see here in results. So for crane 1, you had 88% of the time it's waiting work, 6% of the time it's working, and 5.76% of the time it stopped because it's probably broken down or didn't have a resource, so it was resource starved. Which you can see right here also in the results, which would be 0.19% of the time it was resource starved. And let's just look at crane 4 results here. So when we look at crane 4 results, you can see that here it was resource starved 0.16% of the time, stopped only 0.99% of the time, and the rest is right up here for working and awaiting work. So now from each of these cranes, you have where it's loading the cargo. So there's this queue here, which is the customs queue, and you have the queue for storage facility. So these two queues, it's the same distribution for the routing out for all of these. So you have routing out, and you have a percent, and it's 50-50. So 50% of the cargo will either be sent to the customs inspection, and will go obviously and get inspected, or 50% will be sent to this other queue, which is the storage facility, where the cargo will then just be put into the storage facility. So let's start with the customs. So from the customs inspection, this is also resourced. So there's shift dependent. There's only a certain amount of inspection officers per morning or evening shift, and during these they'll be inspecting cargo. You can look here, and this is a triangular. So this could be, just because it's a human, they could take anywhere from 10 minutes to an hour, just depending on how complex looking at the cargo is. And then there's the mode, which is typically how long it takes. So it could fall in any one of these ranges, but typically it takes 30 minutes, just depending on, how much they have to inspect the cargo. And then if the cargo is found to be illegal, it will get sent to the destruction center and obviously destroyed, which also is resourced. So this is the same thing. During a shift, there's a certain amount of operators, and that determines the efficiency. Here, if you look, it's just an exponential, just fixed rate for how long it's going to take for it to destroy any illicit or illegal cargo. If we look here, you can see 1,074 out of the 14,000 that came in had to have their cargo destroyed because they had illegal cargo. From the customs inspection, if we look at routing out, you can see here 85% of the queue. So 85% of the time when the cargo is inspected, it's not illegal, and then 15% of the time the queue or the cargo is illegal, so it gets sent to the destruction center. And now from this queue, we can look here. So from the cranes, which can be supplied by all 4 cranes to this queue, it goes straight to the storage facility, or after passing inspection, it goes to the storage facility. And this just takes time to sort the cargo or whatever it is and decide where it's going. So if we look here at routing out again, we have 40% railroad and 60% trucking. So that's these two distributions. The lower one is the 40% railroad, and this is 60% of the trucking here. So that's why this is a bigger number. These are also resource driven. So there has to be a certain amount of trains and a certain amount of trucks in the mornings and the afternoons. So these are only running at a certain time, and when there's no trains, no cargo can be loaded onto them, and when there's no trucks, no cargo can be loaded onto those either. And this is a fixed rate. There's also talked about the inspections officer. That's pretty much it for this, other than the resources, and everything is pretty much resource driven. Not much else to talk about for this. Maybe, the breakdown time, talked about that. That's pretty much everything for this port operations cargo. So this is the whole flow. Just going to play it one time at normal speed, just so you can see kind of it going through. So just run it at like a normal speed. See it coming through. Maybe speed it up just a little bit so you can see a different ball. It's a little bit fast, but you kind of see coming through the crane and flowing through every once in a while. You can see a crane operator coming out, depending on the shift. Coming in requires that resource to be used. Flowing through, sometimes it goes into here. Most of the time, it's just going to the storage facility. So that's pretty much it.